Hello, everybody. This is Larry. This is day 17 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. Number of submatrices that sum to target. So usually I solve these live, so it's a little bit slow. Fast forward or watch on 2x or whatever. I just woke up, so it may actually be a little bit slow today. Yeah, let's see. Given a matrix, the number of okay. Hmm. So, mm, so what is the naive algorithm, right? The naive algorithm is just picking the two corners. One is upper left and then the bottom right, and then loop through all of them. And because there's n square upper left corners and n square bottom right corners, it's going to be quadratic in the worst case. In which, given that n is equals to 100, that's going to be too small. Um, this is a really hard problem. Um, because I think there's some like dynamic programming here. That's where I'm thinking about, and just try to think about what is the smart way to do dynamic programming. Because basically, I mean, there's a couple of things that try to figure out as well. The first thing is just going to be prefix sum. The prefix sum part is a little bit tricky because it's a prefix sum on 2 dimensions, both. So yeah, I mean, if that comes to, I'll draw some diagrams. But let me think about how I would use that first, because I'm still trying to figure out how to solve it before, because I do vaguely remember solving a similar problem to this, where yeah, I remember this is a very tough one. With yeah, they say the idea here is going to be, I mean, it's going to be dynamic programming. It's going to be try to figure out the invariant in the thing. I think the first thing I'm going to do, and as I said, I'm summing these live, so feel free to fast forward and maybe watch it. I don't know, maybe I'll do another one in the beginning and recut this. But yeah, I think the first thing I'm going to do is I'm going to write the prefix something and then figure out, because I think there's something that you could play around with that. But yeah, let's do that first. So we get the rows, we get the number of columns, and then we set this to say 0 times. So basically what I'm doing is that I'm using my intuition of prefix sum, which I'll explain in a maybe a little bit, and then try to visualize what that means for me, right? So yeah. I guess I could just do it this way. And there are a couple of ways to write this, but I usually write it this way for some reason. With 2 for loops instead of 1 for loop. I don't know. I don't know if that's the recommended way, but that's the way that I usually do it. Because it's easier for me to make sense of it. And of course, at this point, that's going to be... Okay, my index is a little bit awkward. No, I think I want this, but oops. I had to set up and then now let's print out the prefix so I can see if I can see any patterns on this. I'm thinking of some sort of thing, like prefix dynamic programming as well on top of this prefix sum, but yeah, I mean, I guess this one's kind of trivial. But yeah, so okay. So then now let me help visualize this a little bit. So then, given this input, I mean, obviously when we're looking for 0, it doesn't matter, but let's say we're looking for any other number. What does that mean, right? We call that, as I said, the big thing about prefix sum, and maybe this is where I'll draw a thing. So using prefix sum in 2 dimension, let me pull that up. So what happens is that, okay, so given a matrix, let's say this is a matrix. Let's say that we have, we want to calculate some sum of. So okay, so what does each cell mean, right? Each cell, let's say we're looking for this cell. It gives you the prefix sum gives you the sum of the matrix in this corner, right? Going from the origin all the way to the point that you're looking at, give or take -1. So okay, so then let's say you want an arbitrary corner, an arbitrary box, right? What does that mean? So that means that the prefix sum, you can use the prefix sum by looking at the green box minus, let me choose a better color. I was going to use an orange. That's minus this box minus this box, oops, and then add it to this middle box, right? And the reason is because you remove the parts that you don't want, but then now you remove the blue box twice, so you want to add it back on to get the orange box. So that's basic. I mean, I know that this is very quick, but that's the basic idea about prefix sum in 2 dimension and how to get the sum of any arbitrary square or rectangle, sorry. But yeah. So basically now I know that I have this, but then now I'm trying to figure out, okay, how do I even find the zeros in this, right? Now let's say target is 0, unless I'm misunderstanding this problem. No, that should be right. Yeah, okay. Because that'd be funny if I was solving for the wrong problem. But so yeah, for target equal to 0, what does that mean? Well, that means that my for loop is wrong because this is not showing me the for loop. Huh. Oh, because I did it in a silly way. Because usually I do this looking backwards, so it doesn't change anything. But because I'm pushing forward, I need another for loop to initialize. I'm just being a little bit sloppy. Because looking at this, it doesn't make sense because this should be strictly, well, in this case, it should be strictly increasing. In other cases, they're negative numbers, so that's not quite the case. But yeah, so this looks slightly better. It's also this 0 is a little bit weird. Yeah, because I push forward. That's what I get for messing around. I think I should write this in a little bit better way. Okay. The reason why I did that so that the corners should be better correct, but I was wrong. It's still a little bit off. Oh, I need to Well, I think I may be off by 1 here though. So now okay, no, I had it right the first time. I think I was thinking of some other thing, but I was just adding 1 to it. But then I missed one of the for loops needing to change. Okay, I mean, but that's why, you know, you test incrementally, and I knew what to look for, which is that, you know, I want the corners to be, before, if you look back, the corner was not doing the sum correctly, so I wanted to fix that, because I was missing an, because there's an off by 1. That's a short story. Like basically this cell was not correct, but now it looks like it should be. And now let's see if we can figure out how to get 0, right? Or find the zeros in here. Do I have an off by 1 still? Oh yeah, this is off by 1 because what I wanted was this. Yep, okay. Because I was like, huh, that doesn't feel right. But again, the doesn't feel right part is just because of experience. With enough experience, then you could kind of look at this and be like, oh, I need to debug this. So okay, so this looks better because we want a layer of zeros in F1 because that represents 0 items, at least for me. Okay, so how do we get target is equal to 0, right? I mean, here it's kind of easy because all the matrices are are 1 by 1. It's a little bit deceptive to look at this and try to figure out a pattern because it may be wrong. And I think my hard part of trying to figure out is how do you get any random corners, because then you have to remove you have to remove 2 things, right? Also, something feels off. If this is 0 right here, why is this +1? Did I have an off by 1? I feel like something's off by 1. Huh. Why is this weird? Why are you being weird? Well, this is right, this is right, this is right, this is right. Oh no, this is right. I am just being silly. I was looking at yeah, no, that's right. Okay. So then, you know, this is a 0 because 5 minus 4 minus 4 plus 3 is equal to 0. So that means that this is equal to this for something, right? But then now we're trying to figure out how to do this lookup very quickly. What is this? I feel like I know this one, but now let me think a second, because I don't maybe I don't know this one. Is there any way to think about it backwards? Or am I just on the wrong approach altogether? Because for each of these, that could definitely, like, now we're able to do each of the 2 corners in a like now we can do over 1 for the 2 corners, but I don't think that's fast enough still, right? 100 to the 4th is still going to be a little bit too slow, even if it's really fast. Maybe on a faster computer. 100 million operations is quite a bit on the for Python anyway. How do I get rid of a dimension? How do I make this quicker? How do I check that in fast time? I feel like I've solved this before, but well, okay, what am I asking? So for 5, for this cell, yeah, I mean, I think this is just the 1D version now in 2D, but now I'm trying to think about how to do it in a clever way. I guess n cube is going to be fast enough. So what I want to do is something like so in one that I'm just trying right now. I'm trying to think about the 1D solution and then generalize it a little bit for 2D. Because basically what we want to do is this rolling thing, right? So now let's say we have a target. We can subtract I'm trying to wrap my head around it. Maybe I don't need one of these also. That's besides the point. Too early in the day to wrap this up, but basically now you have the thing, and then we go up to calculate how many times that's short. Okay. Yeah, I think that could work. Okay, I'm just trying to get the right visualization in my head, but so now for C in range of columns, maybe +1. So maybe we have to start from 1. Okay, so now we're given that the 2 rows are fixed. What happens? Let's say this one and this one is fixed. Well, in this case, there's no answer, so that's a bad example. Do I want them to be equal? No, because then you have this offset. Okay. So then, okay, so current is equal to 0. We do current, we add in we add in the prefix of, so now we're trying to get the difference, right? I think this is where maybe I don't need this. I only need the row specific, the column specific one maybe. Let's see. Let's say we have these two rows. We're moving from here, this column to here, right? So then okay, let's say we have these two rows and we start at the first index. So we add in, I think I don't need this on one of them. I forget which. I don't know which one I don't need, but yeah, okay, fine. Is this the right one? Yeah, this is the right prefix. So we only get the prefix rows instead of the entire prefix matrix, which is something that happens a lot maybe. So then now we have this instead. Again, usually I would actually draw this out on paper or something, but lately I've been doing more ASCII arts to, you know, show you guys. Okay. So then this, is this right? Because we want to add this and then subtract this. Maybe this was right. The math is a little bit hard for me to visualize. Okay, so let's say we have this. We want to add this square, which is RC minus this subset, right? Is that right? This is R1C. Yeah, R2C. Okay. Let's take a look at that. What does that mean for me? Let's also remove these things for now, so that our printing is more direct. Lucky I slept enough for this one, because this is tricky. But yeah, let's actually print a little bit more information. And you could use something like this actually for debugging. Something like that. I hope I'm doing that right. Basically what I look at when I look at these things is just that my expectation matches what it should be. And here, and I did R1, R2 in a weird way, but yeah, it goes from 0, 1, and then 2. Is that true? It goes from 0, which is good, this is 1, and then this is 2. So this is a little bit off as we expected, because I think one of these prefix, maybe I need to take out this one. Is that good? No, then it doesn't do the thing. So I think my math needs to be a little bit better. It's basically, it's just adding 5 and then minus 4, but then that's not good because we want to also capture something, right? So we add this, we minus this, we might have to add this back on. No, that doesn't make sense, right? Well, maybe 1 plus. I mean, this is kind of what we were talking about earlier, but C, well, something C minus 1, and this is R2. Does this look more sensible? Okay, so this looks more sense because now the kern is adding the 0. So for the second row we have, well, this is in the second row, but this is the 2 rows. So this is going from here to here. we add 1. Okay, that's good. We add 3. Is that true that we add? Yeah, we add 3, so that's good. And then we have is that 3 total? Is that right? Oh yeah, because we subtract these. So yeah, so just this minus. Well, in this case, it's this minus this because the columns are cancelled out. Okay. So then now, yeah, I just wanted to verify whether this was good. So now we can do, you know, and this is more standard of the 1D version. I definitely recommend that if you're struggling with this one, be very good at the 1D prefix sum DPS. I was kind of mentioning it earlier, actually, but yeah, something like this. Because okay, so basically you want current plus some number x is equal to target. Is that true? What are we searching for, right? Now, because we want the previous indexes that we already looked at, so we actually want the current minus the prefix to get that prefix. So then it's current prefix minus previous prefix is equal to target. So then now, yeah, you add target on this side, you add x on the other side, and you have this. So then this should be the answer, I think. And then now we can print out total. Isn't lookup collections.default int? Okay, that's not great though. Oh, I meant to do that, but I mean, I didn't mean to do that, but I meant to do this, but I forgot about this part, which is critical part of the 1D dynamic programming that we were talking about. That's unfortunate. So let's let's do more debugging. Okay, so first current is 1. Oh, I have to set up 0 first. I think that's what I already, because that's the prefix of when there's no element. New mistakes, that always gets me. But okay, but this is still wrong, unfortunately. Okay, adds 1 afterwards. That's good. Adds 2. Current plus target. Did I mess up that? I always mess up on these signs. But current plus target. Did I mess it up? So basically we want the count of this. Oh wow, how did I just messed up the sign again. So this is minus target on this side, and then minus x, no, plus x on this side. So this is, yeah, okay. Math is hard. Okay, this is still the wrong answer, unfortunately, but hopefully this is a slightly less wrong answer. So the current is 2. We're looking for the prefix of 2, so that's not going to be 1. 1, we're looking for the prefix of 1. I think this is fine, except for that we need this to be plus 1, because I think we're looking at 2 rows maybe. Now that doesn't make sense. Well, now there's way too many, but because we double count the zeros. So now this isn't quite the way. But I'm missing one thing because my matrix here prefix is wrong. So I have this, but it doesn't ever count. It doesn't count something. I'm undercounting a little bit because this never returns. This never gives me anything good. I mean, we could just print out the total as we go, but yeah, this is all on the last column or last row or last row combination. But clearly, this should be here. I think I'm missing. I think this is why. Okay, because I'm missing one of the rows that allow us to do this row. So yeah, okay, yeah. And this is why, you know, I did speed through this part a little bit, which is unfortunate, because because what I was going to say is that, you know, when you see off by ones, you have to really go back and figure out why you're having off by ones, and the usual reason why is because you didn't define your bounds correctly. And I kind of got a little bit lazy here, with just like be like, oh yeah, this is one, so this should also start one. But we actually needed that zero thing to kind of count the first row. Let's see. Okay, cool. Wow, that's good. Yeah. So what I would say is that if you're unfamiliar with the 1D version of this problem, I'm going to pause right now and kind of give you some homework, because I think this is something that's very handy to kind of look up. So I'm going to, well, I mean, you can't see it because I'll cut it backwards, but I'll pause and then kind of give you homework on later. But let me explain this problem in terms of the 2D version. Yeah, I'm gonna pause. You can't really see it because this is technology and I'll edit it out, but or just, you know, pause it out. But I'll find a prompt so that you can understand the 1D version, and then once we understand the 1D version, then the 2D version will be slightly easier. Still won't be easy, but will be slightly easier. Hang on. This was actually easier to find than I thought it would be. But okay, so basically the idea is, you know, and this is subarray sum equals to k, problem 560 on Leetcode. So definitely, if you know, well, first try to practice it at home and try to get it by yourself. And this is basically the 1D version, right? The 1D version will ask you to have, and this is good that this is a Saturday, because otherwise I may be too tired, and I just got in sleep. But yeah, so naively you would have an n square solution, right? And you're trying to compress it to one n, or O of n instead, right? And the idea is that you have this prefix sum, right? So let's say you have some array, you know, 1, 2. Well, this is just some array, and there's some. Is there a negative number? There's negative number, right? Right, and then now you have a prefix sum, right? Yeah, you now have some prefix sum that start with 0 because of the no elements. Then you have 1, you have 3, and I'm doing this manually, so hang on. So something like that, right? So that's the prefix sum. Actually, let me edit this prefix sum to be smaller so then I can, yeah. And then now you know, this is the prefix sum again. And then now you can ask yourself in the same way, for each index, right? How many? So this is we know that. Oh, let me actually bring out the drawing again. So this is the 2D version. I'm going to erase it. Oops, the technology is hard. Hang on. So basically the idea is, okay, you have some number line, you know, you have this line, and you have the prefix sum, which tells you the sum for, oops, let's say we have the sum for this portion, right? Let's say, you know, our pointer is here. then now you're trying to figure out, okay, this is, let's just say this is current. Oops. Okay, let me type it. Let's just say this is current. Why is my computer so slow? Huh. Okay, my paintbrush just crashed. Hang on. Technology, am I right? Oops. Yeah, so then sorry friends. But yeah, let's say you have this segment, we have this pointer, and this is current. Let's just write cur, because I don't know, things keep crashing. And then now we know that we want some target, total k, right? And then here we want to keep, simultaneously at the same time figure out, okay, what is let's say we want, let's just say there's some previous thing, right? Previous here. We know that we want some current, man, handwriting is terrible, minus previous is equal to target, right? In this case, this is k. We have this formula here. And as we did before, then now we just want to know that we're looking for, in the previous thing, we want current minus k is equal to previous, right? And then now, the very naive algorithm would be, okay, the way naive way to do this would be, okay, now we have, so I'm changing colors, oops. Now we have this section, and then now we're trying to iterate by brute forcing, what is the previous here? What is the previous here? What is the previous here? Right? What is the previous here, right? So then, we check whether the prefix sum of each of those things of the previous equals to the number that we're looking for. So we're looking for this number, and we're just checking one at a time whether these things are looking for, right? And the key thing to know here is that, well, this is what a hash table would serve, right? Because now, as you go through, now we could pre-calculate all of these numbers and do the number count, so then we don't have to go this for loop one by one. So that's basically the optimizations that we're doing here, and yeah, and this is basically the way that I did it, right? I have a running sum. I set the 0 to 1 in the beginning, like I did, and then here I go, okay, let's do all this funky stuff that we talked about. This gets the prefix sum, which gets this element, and then the previous, we go, okay, the previous is just equal to the running sum minus k. Let's just say k is 1 in this case. Then this will be looking at previous 1. And now this is just a simple hash table lookup and adding it, right? And then at the very end, we want to add this back to the list. So basically, that is the 1D version. It's kind of tricky. I don't know that I'm explaining it super well, but definitely you have to be familiar with this. And once you do, this is a way harder version of it, but here it is the same thing, except that it's a 2-dimensional version where, let me put up this up again. Oops. So now instead of, we brute force on the rows and on the 2 rows. So then now you have this slice. So now we basically, this is R1, or in my case, this is R1, R1. This is R2. And yeah, we have basically we have some prefix sum. So this is our current running sum, if you will, in the same way. And then now we have some target. I'm just going to call it K because it's hard to draw. And then now we're trying to figure out, okay, for given this K, this target, how many different prefix, the previous's are there so that this thing matches up, right? And that's basically it. I think I was trying too hard to try to solve this in n square, but n cube is going to be fast enough for this problem, and I will show you my code again. This is actually the complete code, but yeah, but that's basically the idea behind this problem, and it's very tricky, at least for me. And you can kind of, the complexity I think is pretty straightforward to analyze. For space, this is n squared or n times m or r times c, depending on your notations. In this case, this is going to be r squared times c, and without loss of generality, you can also, choose a smaller, so you flip that to c squared r if you want. But, these are just 3 for loops, so that's easy to analyze. And yeah, cool. That's pretty much all I have. It's a long video. It's a tough problem. It's a tough thing. As I mentioned again, if you have trouble with the 2D version, first do the 1D version, which I did the luxury of kind of giving you the number. But yeah, let me know what you think. Let me know if you're doing the contest, contests today. Good luck. Have fun on your journey, and I will see you later. Stay good, stay healthy, stay well, and to good mental health. Bye bye.